Hi, welcome to this video where we'll be going through the solutions for consultation worksheet 18, alright, which is on the chapter 8 of our year 4 notes on further integration. Without further ado, let's begin question 1, part 1, where we are supposed to integrate sine half x plus cosine half x, the entire thing square dx. Okay, so as we see here, we are unable to straight away immediately integrate the function because of the square here. Okay, so we need to perform an expansion, alright, a quadratic expansion to give me sine square half x plus 2 sine half x cosine half x plus cosine square half x dx. Okay, and I hope immediately you are able to see that we have a sine square half x plus cosine square half x, which you can apply the trigo identity to give me a 1. Alright, plus, and next we see here we have a 2 sine half x cosine half x, okay, which we can apply the double angle formula if you have forgotten. 2 sine A cosine A is the same as sine 2A. Right, so in this instance here, the A is like our half x. So what are we expected to have? Alright, we're expected to have a sine x itself, okay, with a dx here. So let's continue our integration. We are expected to have a x minus cosine x plus c, okay, where c is a constant. Alright, so that will be part 1. Alright, for part 2, we are supposed to integrate tangent square bracket 3x minus 2. Alright, as we all know, in chapter 8, and our earlier part of the chapter, we have not learned how to integrate tangent square immediately. So what we need to do is to apply, again, our trigo identity. Okay, so in our trigo identity, we have learned that secant square x minus 1 is actually our tangent square x. Alright, so we're going to rewrite our above function that we need to integrate in terms of secant, and that will give me secant square bracket 3x minus 2 minus 1 dx. Alright, and that will give me 1/3 tangent 3x minus 2 minus x plus c. Alright, where c is a constant. Alright, a very common mistake we observe is when students will omit the 1/3. Okay, do remember that we perform a chain rule when we differentiate tangent 3x minus 2, and there was a 3 outside. So therefore, since the function that we were to integrate, there is no 3 outside, alright, we have to multiply it by 1/3. Alright, for part 3, you are supposed to integrate e to the power of 2x minus 1, the entire thing square over e to the power of x. Okay, as similar to part 2, some simplification is needed for the expression first, okay, before we continue to integrate it. Alright, in this case, like our part 1, we have to perform the quadratic expansion at the numerator, and that will give me e to the power of 4x minus 2 e to the power of 2x plus 1 over e to the power of x dx. Okay, and from here we are unable to integrate, please take note, the numerator and the denominator separately. Alright, there's no such rule in integration for now. So what we need to do is to simplify the expression first, and that will give me e to the power of 3x minus 2 e to the power of x plus e to the power minus x dx. Okay, and from here, performing the integration, we will have 1/3 e to the power of 3x minus 2 e to the power of x minus e to the power minus x plus c, where c is a constant. Yes. Okay, and usually we will write our answer in a positive index, meaning this term. So we will rewrite our answer as such. Alright, so there you go. This is the answer for question 1 part 3. Alright, for question 2, please note that there's a typo in the question. Please change this to 4x cubed minus 25x over x squared. Alright, so let's read the question again. A curve passes through a point 1, 9, and its gradient function is given by 4x cubed minus 25x over x squared. Okay, and we are supposed to find the equation of the curve. Alright, this may look similar to one of the question in paper 2 of your common test lah. Alright, so what does it mean by the gradient function? Okay, I hope you recall that this is actually our dy dx. Alright, which we have it to be 4x cubed minus 25x over x squared, which we can simplify it further to give me 4x minus 25 over x. Alright, so from here on we can integrate both sides to give me y to be the integration of whatever we have written above dx. Okay, and this will give me 2x squared minus 25 ln modulus of x plus c. Alright, where c is a constant. Okay, this is a general form of this curve. So since a specific point is given, we are able to find the value of c to get our unique equation of the curve. Alright, so let's do that. We're going to sub x equals to 1, y equals to 9 into y. Okay, then we will have 9 to be equals to 2 minus 0 because ln 1 is 0 plus c, and this will give me c to be 7. And therefore, our equation of curve will be y equals to 2x squared minus 25 ln modulus of x plus 7. Alright, for question 3a, we are supposed to express the given fraction in terms of partial fraction. Okay, I hope that you recall that the given fraction can be expressed in the form of a over 3x plus 1 plus bx plus c over x squared plus 4, because for the second bracket we see here is actually quadratic. Okay, and we need to define our ABC. Okay, so from here on, what I'm going to do is I'm going to combine our right hand side into a single fraction, and I'm going to use a bit of substitution and comparing coefficient to give me my values of a, b, and c. Okay, so for our right hand side here, common denominator, I should have a bx plus c, and then a 3x plus 1, alright, the entire thing over 3x plus 1, x squared plus 4, and my left hand side remains unchanged. Alright, so since the denominator is the same on left hand side and right hand side, right, so I can just compare the numerator, alright, which is 8x squared plus 2x plus 8 equals to a bracket x squared plus 4 plus bx plus c over 3x plus 1. Alright, so from this juncture, some of you might want to compare coefficient to form 3 equations in terms of a, b, and c, and solve. Alright, but for me, I recognize that the second term here, if I sub x to be negative 1/3, it actually becomes 0, right? Okay, and straight away, which value do I find? Yeah, I straight away will be able to find a. Okay, so let's do that. So let's sub x to be negative 1/3. Okay, so on the left hand side, I will have a 8 bracket 1 over 9 minus 2 over 3 plus 8. That will give me a 1 over 9 plus 4. Okay, and as mentioned, the bx plus c it become, and the 3x plus 1, the whole thing becomes 0. So solving this, my a will simply be a 2. Alright, so if you were to compare the coefficient of x squared, what happens here? We see that coefficient of x squared comes from a, and also bx times by 3x. Okay, so if we compare the coefficients of x squared, Okay, we will have on our left hand side to be a 8 equals to a plus 3b. And since we know a is 2, we can solve it to give us b to be 2. Alright? Alright, so that leaves us with finding c. Likewise, I'm going to compare the coefficient, or rather the constant term now. Okay, so as we can see here, the constant term comes from a multiplied by 4 and also c multiplied by 1 and nothing else, right? Alright, so let's write this equation down to give you our c. Alright, so before that, let me shift it out. If you have not copied, don't worry, pause the video and you can just write it down. Yeah. Alright, so if we compare the constants, okay, we know that we have, if you can see earlier, our original left hand side, okay, it is a constant is 8 lah. Okay, so let's continue. Our left hand side, that would be a 8 will be equals to 4a plus c, and since we know that c is 2, our c is 0. So therefore, we have our original question, 8x squared plus 2x plus 8 over 3x plus 1 x squared plus 4 to be equals to 2 over 3x minus 1 plus 2x over x squared plus 4. So congratulations, that would be the answer for your first part of the question. Alright, so in the next slide, I will be going through 3b. Alright, in 3b, we're supposed to integrate the fraction that we had in 3a, and by partial fraction, we already realized that this is essentially integrating 2 over 3x plus 1 plus 2x over x squared plus 4 dx. Okay, as we can see here intuitively, what is the end product that we're supposed to have after you integrate? Yeah, okay, we're going to have the ln function. So the first part here, you're expected to have a 2 over 3 ln modulus of 3x plus 1. Alright, and the second part, I'm supposed to have a ln modulus of x squared plus 4. In fact, do we really need the modular sign for x squared plus 4? No, right? Because the inner term is always positive. So in fact, we can drop the modular sign to write this as bracket x squared plus 4 plus c. Alright, where c is a constant. So that will be our answer for 3b. Yeah, so as you watch this video and you consult, if you have doubts, please pause the video and ask your teacher. Alright, welcome to question 4. Okay, you are given the derivative of f, okay, and you are also given a point. If you were to read this properly, it means that, okay, when x is actually pi over 2, the value of your f when x is equals to pi over 2 is actually half. Alright, and why do you need that? I will explain that later. So what is the objective of this question is you want to prove that the second derivative of f plus the original function of f, 4 times the original function of f, right? That will give me 4 minus 3 sine 4x. Alright, so this is something like a proving question where we want to show that the left hand side will equal to the right hand side. Okay, and this is a hybrid question per se. Why? Because as you can see here, to find the f double prime x, we are given f prime x. Right, so first thing we probably need to differentiate f prime x to give us the f double prime x. Alright, but yet on the second term of 4 multiplied by fx, we cannot differentiate our f prime x again, right? So we are supposed to, integrate our f prime x to give us our fx. But we all know here that since this is still chapter 8, this is an indefinite integral. When we integrate it, we're expecting to have a plus c. Alright, so as similar to our question 2, when you have a c, what do you need to do? You need to find the unique fx, right? So that's why we have the x half, x pi over 2, sorry, when x is pi over 2, your f is half, there, to find our c. Alright, so without further ado, let's begin the question. Okay, so let me just shift this up. So first thing, I would prefer to find our fx first. Alright, so our fx is simply the integration of cosine 4x minus sine 2x dx. Alright, and that will give me 1/4 sine 4x plus half cosine 2x plus c, where c is a constant. Okay, so since we have f of pi over 2 to be half, we will have half to be equals to 1/4 sine 4 pi over 2 plus half cosine pi over 2 times 2, which is simply pi, plus c. Okay, so from here we know that this is actually 2 pi, right? So sine 2 pi is 0. Alright, so we will have a 0, and cosine pi is simply minus 1. Alright, so we will have a plus half multiplied by negative 1 plus c, and our left hand side, let's not forget, is a half there. Solving this, my c is just 1. Okay, so I will have my fx to be 1/4 sine 4x plus half cosine 2x plus 1. So there you go, that is our fx. Okay, so as mentioned earlier, we also need our f double prime x, okay, which is simply differentiating our f prime x in the question. Okay, so if you perform the differentiation, you should have negative 4 sine 4x minus 2 cosine 2x. Alright, so now that we have our ingredient, let's start with the left hand side. Okay, so if you refer back to your question, okay, we are supposed to, alright, get the expression on the right hand side to be 4 minus 3 sine 4x. Alright, so let's continue our working, and let's begin with our left hand side. Okay, our left hand side, we have a f double prime x plus 4 times of f prime of x. Alright, sorry, fx. So this is 4 times of fx. Okay, so this will be minus 4 sine 4x minus 2 cosine 2x plus 4 1/4 sine 4x plus half cosine 2x plus 1. Alright, so as you can see here, if you expand the second one, let's write down the first one first. First part. So this will give me sine 4x plus 2 cosine 2x plus 4. Alright, and here we see that our cosine 2x, negative 2 cosine 2x and 2 cosine 2x actually gives me 0. So eventually I would have a 4 minus 3 sine 4x. And this is essentially our right hand side. And you can proudly write shown. Okay, so that will be our working for question 4. Alright, welcome to question 5. Okay, in question 5, we are supposed to do two things, yeah? So first thing, we are supposed to differentiate 5x plus 2 multiplied by ln 2x plus 1 with respect to x. And after that, we are required to find, alright, the indefinite integral of a function that looks very similar to my differentiated question. Alright, so let's start with the first part here, okay, where we are supposed to differentiate 5x plus 2 ln bracket 2x plus 1. As we can see here, this is a product of two functions, 5x plus 2 and ln 2x plus 1. So we're going to perform the product rule. Okay, so when we perform the product rule by differentiating the first term, I'm expected to have this. Okay, and then if I differentiate the second term, which is the ln term, I'm expected to have 2x plus 1. Alright, and because of chain rule differentiating 2x, I should have a 2. Okay, so if I were to rewrite this, I can rewrite it in this way. 2x plus 1 plus 2 bracket 5x plus 2 over 2x plus 1. Alright, so there you go. This is the differentiated form for our first part of the answer. So we see in the second part of the question, we are supposed to integrate, alright, ln 2x plus 1 to the power of 3 dx. Alright, we see here that in our final result, we do not have a ln 2x plus 1 to the power of 3, but we do have a ln bracket 2x plus 1, yeah? So that's the approach that we want to do when we integrate both sides of this equation here. Okay, but before that, as we learned from logarithm, we can simplify this to 3 bracket ln 2x plus 1 dx. Okay, so our objective for the next part is to get this result. Alright, the integration of ln 2x plus 1. If we can get that, and through some manipulation, we should be able to get our answer. Alright, so if we were to integrate the above, this, with respect to x, so we will have back bracket 5x plus 2 ln, bear in mind this is integration now, we need to put in the modular sign. Alright, 2x plus 1, okay, plus c, because now there is a constant when we integrate both sides. Alright, so this will give me the integration of, let's keep the 5 outside, alright, 5 bracket 2x plus 1 dx plus the integration of 2 bracket 5x plus 2 over 2x plus 1 dx. Alright, so we see that what we want above, as you can see underlined in green, is appearing already on our right hand side. But let's wait a minute, let's take a look at the second term that we are supposed to integrate here. Are we able to integrate it immediately? Well, no, right? Because if you look at the degree of the numerator and the degree of the denominator, they are both power 1. So this is an improper fraction. So we need to perform our partial fraction, okay, to decompose this fraction first. So with that, so let's write that down. So we let 2 bracket 5x plus 2 over 2x plus 1 be equals to a plus b over 2x plus 1. Alright, so we have to multiply 2x plus 1 on both sides. We will have the end result to be this. Alright, so if we were to expand it, and then we can compare the coefficient plus a plus b. So if we compare the coefficient of x, we will straight away see that we have 10 is equals to 2a, and we will have a to be equals to 5. Okay, so likewise, if we compare the constant term, we will have 4 to be equals to a plus b, and since b is equals to, since a is 5, we will have b to be negative 1. Alright, so let's rewrite our fraction. We will have 2, therefore, alright, 5x plus 2 over 2x plus 1. This will be 5 minus 1 over 2x plus 1. Okay, so that means that we can rewrite this above in this form, and we all see that this is easier to integrate, right? So let's rewrite this part from the start. So we have, okay, bracket 5x plus 2 ln modulus of 2x plus 1 plus c, alright, where c is a constant. Alright, so we probably need to add it here since we haven't written it earlier. Okay, this is equals to 5 integration of ln 2x plus 1 plus, oops, sorry, I forget the dx, plus the integration of rewriting it in the partial fraction form, yeah? 1 over 2x plus 1 dx. Alright, so there we go. We can start to differentiate the second one at ease. Okay, at this juncture, you might want to pause the video to copy everything down. Okay, because I'm going to shift the terms up and perform the differentiation. Okay, let's begin our integration. Alright, the terms on the left hand side remains the same. Plus c, and we're going to keep our first term on the right hand side and perform our integration here, which will give me 5x minus half ln modulus of 2x plus 1. Alright, as per every integration, we need to have a constant. Alright, and this constant here, let's call it d. Alright, where d is a constant. Okay, we are almost there to get our answer already. As you can see, the required answers are all integrated. This is what we want, except that the coefficient now is a 3, not a 5. Okay, so let's keep our 5 integration of ln 2x plus 1 dx on our left hand side now. Okay, and the other terms we're all going to keep it on the right hand side. Alright, so we will have 5x plus 2 ln 2x plus 1 plus c minus 5x plus half ln modulus of 2x plus 1 minus d. Okay, as we see here, there are like terms where we have a 2 multiplied by ln modulus of 2x plus 1 and also the half multiplied by the modular ln of modulus 2x plus 1. Alright, so let's simplify that. We will have a 5x ln modulus of 2x plus 1, and we have a 2 ln modulus of 2x plus 1 plus half of the ln of the same thing. We will have a 5 over 2 ln modulus of 2x plus 1. Okay, not to forget our negative 5x and also our constants. Okay, so this is 5 of the ln of 2x plus 1 dx, which is very close to what we want already. Remember what we want earlier is a 3. Alright, so from then on, we are just multiplying by 3/5 to the entire function we had above. Okay, so in other words, we can finally simplify this to give me 3x ln modulus of 2x plus 1 plus, is it 5? No, it should be 3 over 2 ln modulus of 2x plus 1 minus 3/5 times 5, which is simply a 3x. Alright, and I'm going to call a new constant e, where e is simply 3 of c minus d over 5. Alright, so you still see here that there's two constants being defined, d here and the c here, because at the start we integrated the dy dx on both sides, so there should be a constant at the start, and this d is because of integrating the second term. Yeah, so that will be our final answer, and let's make our working clearer by giving the marker what is intended at the start, which was power 3 dx. Alright, so that will be the answer for our question 5. Alright, if you have any question, feel free to ask your teachers. If not, thank you for watching the video.